All right, guys, this next set of problems is extremely similar to what we did with the first page. We have some new figures, and we are in a new country, the country of Transylvania. So again, using the same formulas that we used on 1 through 4, we are going to work through density, birth, death rates, growth rates, and double time. So the current population density, we need the total population, which is the 2.3 million. And we're going to divide that by the area. The total area is 800,000 kilometers squared, giving us a density of 2.88 people per kilometer squared. For number 6, our birth and death rates. Again, I prefer to calculate crude birth and death rates, which makes the math a little easier when we're working for that R, that growth rate. You can do this either way. If you would like to calculate the crude birth and death rate, you would take the deaths divided by the population, multiply by 100, then births divided by the population, multiplied by 100, and you would report your answer in a percent. If you are calculating crude birth rates, you would do so as following. We would take our number of births, which in this case is 109,000. We're going to divide that by the total population. And instead of multiplying by 100, we are going to multiply that by 1,000, giving us the number of births per 1,000 people. And for this example, that equals 47.39. And then we can just write for our unit per 1,000. Sometimes I write births per 1,000, but if I have that I'm solving for crude birth rate with all my work, I know that this is births per 1,000. If I don't have my problems labeled as crude birth, crude death, then I may want to write births or deaths per 1,000 in my final answer. All right, so for our crude death rate, we're going to take our current death rate, which is 111,000, divide that by the total population of 2.3 million, multiplied by 1,000, giving us a death rate of 48.26 deaths per 1,000. Okay. Solving for the population growth rate. Again, this can be done a couple of different ways. If I'm solving for the growth rate, I could take the number of births minus the number of deaths divided by the total population multiplied by 100. We would get the same answer as taking our shortcut by using our crude rates. That would be 47.39. So that's the crude birth rate minus the crude death rate of 48.26. And we would divide that by 10. Now, just looking at our figures, I see that my death rate is higher than my birth rate. If the death rate's greater than the birth rate, that means more people are dying than being born. So I should expect my growth rate to be negative, that my population is actually declining. And in fact, if we solve this out, we get 0.087%, and that would be negative because our population is in decline. Moving on to 8, how long would it take a population that is in decline to double? Well, unless something changes, unless this growth rate changes, your population will not double. It is in decline. So the correct answer for 8 is actually NA, due to the population declining. All right, given a world population growth rate of about 1.3 per year, how long would it take that population to double? Well, our formula for double time is 70 over the growth rate, which in this case is just 70 over 1.3%. Giving me a double time of 53.85 And then again, the unit on double time is always years. The second part of that, how old will you be when this doubling occurs? This is really interesting. We're looking at the growth rate of our planet. So if you add your age to your answer, it will give you how old you will be when our population will double. Right now, we're at about 7.7 billion. Okay, so we will be close to 16 billion when most of you are in your 60s. Moving on to number 10. If a country doubles its population in 56 years, what happens to the growth rate, or what is the growth rate during that time? Using the same formula, we're given our doubling time, 56 years. We know that the 70 stays there. We're solving for R. So as I was working around the room, when you guys were solving your problems and working with students in MATLAB today, I noticed that several of us had problems solving for variables in the denominator. Okay, it's been a while since you've been asked to do this. In chemistry, we did it all the time. One trick that I taught my kids in chemistry, or a method that we used, was the cross multiply and divide. That sometimes it's a little tricky in the denominator, and if we don't want to work through the steps to solve for R, we can just set 56 over 1 and cross multiply, which would give me 70. Set that equal to 56 times R. Okay, now it's really simple to solve for R. We would just divide both sides by 56. This would cancel out, and my growth rate is 1.25%. All right, on number 11, calculating the growth rates and doubling times for the countries listed below. Again, in MATLAB, I had some questions from students. Given that the birth rate and death rates did not specify whether this was a crude or a percent, I will tell you that if you don't see percent in the heading, that it's not a percent, assume it's crude. Also, if you look at the values, 13, 19, 23, 41, that would be an extremely high percent of the population having babies every year. So these are absolutely crude birth and crude death rates. Knowing that, we can use that shortcut for R, and actually we don't have another choice because we don't have the total population. Unless you had the total populations of the nations, you wouldn't be able to do this using the other formula. So we are going to use R equals crude birth rates minus crude death rates divided by 10. That should give us our growth rate in a percent. And then for doubling time, you plug that in. Your doubling time is 70 over R. So all you do is you get your value that you calculated for R, plug it into this formula, giving you your double time. Okay, so I'm not going to go through the entire list. I will do a few of these for you so you can spot check yourself, starting with the first one. This would just be 13 minus 8 divided by 10, giving me a growth rate of 0.5%. Going down to Japan, 8 minus 9 divided by 10. This would give us a negative 0.01%. Okay, let's look at South Africa. 21 minus 14 divided by 10, 0.7%. Okay, so if I want to calculate the doubling time for all of these, it would just be 70 divided by the 0.5, in this case, 140. Japan, we have a negative growth rate, meaning our population is in decline. We would not have a doubling time. For South Africa, 0.7, so this is 70 over 0.7, giving us a doubling time of 100 years. Okay, you would use the exact same method to solve the rest. Make sure you have all of your math